Yeah. Hi, everyone. Please do let me know if you could hear me. Can you hear me, please?
Yes, we can hear you and see your screen as well. You can proceed.
Okay. Okay. So, my name is Osinachi Mbakamma. So, I'll be presenting this topic together with my teammates, Zhujun, Joiakim, with the guidance of our mentor, Ayodeji, Ibitoye. So, we are here today to explore an important question. Can AI doctors be fair? As AI becomes more useful in medical decision making, we need to ensure it doesn't inherit any bias, especially as compared to human doctors. And this is the main ideology behind our research topic that has to do with AI doctors. Can AI doctors be fair? Next slide, please. So, according to research published by the British Heart Foundation, women are 50% more likely than men to be misdiagnosed after a heart attack. And now, imagine an AI system trained on such a biased medical record, which makes those decisions. Would it truly be fair? And this leads us to a question which has to do with, for instance, uh, when discussing gender bias in clinical AI, especially focusing on large language model, which is the main focus of this presentation. These AI models are trained on vast medical tests. But what if the data that is used in training this data set are biased? So instead of reducing the disparity uh, in those decisions, AI might actually help reinforce those challenges that we face in such research. So also, this issue is also a critical one because AI is being integrated into hospitals and clinical decision making. And if these systems inherit human bias, they could also contribute to healthcare inequalities instead of solving them. Next slide, please. And this is why we are to explore these key areas in the course of this research topic, which include first is the existence of bias in healthcare, especially by leveraging bias in large language model, which was our primary focus, where our primary focus is on gender bias. We also explore further in sources of this bias and also further elaboration on how to resist this bias. Now, let's begin by understanding how bias exists in an actual healthcare. And to explain this further, I will hand over to my teammate, Zhujun, who will give us practical insights into our findings. Thank you.
Cool. So first, we explore if large language models do behave with implicit gender bias in the medical context through role play. So basically, we ask Lemma to construct patients' images based on their patient history notes, and the image has to include gender, occupation, and social economic status. And we are using patient history from this Kaggle challenge, which collects notes by test takers of the USmile exam, in which they interacted with standard patients. This means that for the same patient, we can have multiple versions of patient notes, and this diversity can further help us identify sources of bias. So here is an example patient history notes we showed to Lemma, and we removed all gender-related terms like names, pronouns like he or she, and his or her. And this is the image Lemma constructed about this patient. And we can see here that Lemma assumes people with access to healthcare are from like middle-class family, and this already indicates the the typical weird cultural problem. The dominant population of the training data is very likely to be Western, educated, industrialized, rich, and democratic. In other words, other populations can be underrepresented in large language models like Lemma. I go back to the gender bias we are targeting at. When we asked Lemma to guess the gender of this patient on the first try, it made a guess of male. When we gave it another version of the patient history notes on the exact same patient, it made a guess of female. And if we were to compare the reasoning it gave in these two examples, it gave almost identical reasoning. And these results not only indicate that large language models like Lemma may have like certain stereotypes, but also highlight that they may frame their answers in a biased way just based on the prompt you give to them. Having shown that large language models can be biased, we want to further look for sources. And one potential source is data, as mentioned in the introduction. Because words need to be transformed into vectors through word embedding, any bias in the set of words will manifest in this vector space. For example, here's the classic bias in occupation gender association, that male and female are each like more associated with certain occupations just because word vectors indicated such relationships. So we look at word embeddings under medical context in two language models, a more domain general based bird based and a more domain specific bioclinical birds. To be specific, we look at the distance between male and female and different medical symptoms here. For more neutral symptoms like fever here, it is equally distant from both genders. However, for certain symptoms like weight loss, it is gender bias in the domain general bird base, but not in the domain specific bioclinical birds. So here we can see this. So how would this affect decision making in models in real life? And so we did the last analysis. That is, we explore the effect of bias in data and that in word embeddings. We can see that in our data set, there is already a bias that we have more female cases. And we can then test whether models make biased predictions under such circumstances. And my colleague Joiakim will introduce more about this analysis.
Thank you very much. So we do know that large language models are trained on lots of text, and we know that the data that we use could be an example of the data that we would train these large language models on. And for that, what we did was we took a patient note and we marked the gender terms and certain symptom terms. And for other experiments, we marked both gender terms and symptom terms for the two models, which was the bird-based and the bioclinical birds. And we were interested in how the models would predict the gender in a patient's note. So was that we were interested in. So the next slide. We were interested in extracting the genders that would be predicted for the patient notes, then these terms that had higher probabilities. And so if for a patient's notes, our max language model with the bioclinical birds or the birds predicted more male terms for a certain patient note, we ascribed to that patient note that being male dominant, and if it had more female terms, we ascribed that being female dominant, and if it had mixed terms for the genders, we ascribe that patient note as being mixed. So for our next slide. And what we did for the experiment was that we first matched gender and symptom terms for the birds based on case. We used the bird based on case and later bioclinical birds. And for that, we could see that there were more dominant male terms for the birds based model, using the bird based model. And then for the bioclinical birds, we realized that there was more male dominant terms as compared to the female and the mixed term. And then our experiment 3 and 4, what we did was to max only the gender terms and max gender terms for both the birds and bioclinical birds to look at the changes. And we realized that now we had more female terms being predicted as opposed to bioclinical birds where there are more male terms being predicted, but there's an increase in the female terms that were predicted earlier. That was for the maxed term. So over to the summary and the discussion. This shows the importance of how the bias in data can transfer to the model, and you should be cautious, especially for the medical context, which is something very sensitive. And you should also know that these models behave in different ways in regards to the gender bias. There are also ways that we can mitigate these biases in data sets. And an example would be the projection-based debiasing, where you normally project these sensitive terms onto a neutral space or subspace to reduce or to mitigate these biases. And also from the prompting technique that we use with the Llama model, an interesting fact would be that the model's decision, or something that we could look at, would be the model's decision in choosing some sentence to tag the patient as male, and this varied for different large language models. So now, if you decide to employ these large language models in the medical context and they behave the way that you do not expect them to, and they are being biased, then you should turn and look at the data that we have trained them, or the data that we are using we are using to treat, or we are using to recommend these diagnoses for our patients. So thank you very much for joining this session.